The ENS220, you get 3-in-1. First off, it's a state-of-the-art absolute pressure sensor. It can measure the barometric pressure of the environment very accurately to 0.5 hectopascal. Where it becomes very interesting is actually the relative pressure sensing. That means you want to measure pressure changes in the environment. We can measure it with the highest ODR and resolution at the lowest power consumption. Our pressure sensor also includes a temperature sensor. It has an accuracy of 0.1 degrees Celsius, which is quite impressive for pressure sensors.
Hey, it's Eamon with ipXchange with a very special ipXperience in preparation for Embedded World. So I'm here with Jan and Guido from ScioSense, and they're actually joining us on our booth this year with a demo of the ENS220, I believe.
Right.
So yeah, Jan and Guido. Anyone who's seen your booth before at a show will know the balloon demo. So do you want to give a little explanation of the balloon demo with this innovative pressure sensor?
So the idea for the balloon demo is we have a pressure sensor here floating on the cable, and we have another pressure sensor that we use as a reference.
It is actually inside here, yeah, in the black screen.
And the idea of why you would need two pressure sensors to measure a change in height, which of course the height means that you have a different pressure. If you go up, you have less pressure. And the reason to use two sensors instead of only one, because only one is perfectly okay to measure, is that the pressure changes in the environment throughout the day, throughout the year, is way more than what you can experience with just a couple centimeters. So our sensor is accurate enough to measure this change, but the problem is you need a reference to be able to exactly what's the pressure difference between the two. Mm-hmm. This was our original demo. Before it had one big balloon, and now we are changing things a bit, but still it's not that new, not that different. So we already have some new ideas coming on the pipeline. But I would like to know if there are questions regarding how the demo works or implementations.
Excellent. So I guess the first thing that people want to know is what sets your pressure sensor apart from other things on the market. I know there's some very high accuracy because some of our engineers have been testing it for fall detection. But if you could give an overview of what makes the ENS220 so special, go ahead.
Actually, with the ENS220, you get 3-in-1. So it's First off, it's a state-of-the-art absolute pressure sensor. That means it can measure the barometric pressure of the environment very accurately, actually to 0.5 hectopascal. But this is, usually you use that in weather station, and it's not the real challenge for a today's pressure sensor, let's say. Where it becomes very interesting is actually the relative pressure sensing. That means you want to measure pressure changes in the environment. And so our sensor can do best in class. That means we can measure it with the highest ODR and resolution at the lowest power consumption.
And just ODR is output data rate, so you can acquire a lot of data, which is really interesting when you want to see some pressure events, some cases that we will talk about that later.
And actually, the last thing is the temperature accuracy. So our pressure sensor also includes a temperature sensor. And this is, it has an accuracy of 0.1 degrees Celsius, which is quite impressive for pressure sensors.
Mm-hmm.
Excellent. So we won't spoil the variation on the demo that we'll have on our stand at Embedded World, but it will be another one to do with determining height. One of your team recently posted a blog on the ipXchange community page about a door opening algorithm. So would you like to explain a bit more about how this pressure sensor can be used to determine the opening of doors.
Exactly. So with the demo which Guido just showed now, this is one case of measuring of relative pressure sensing, so the height changes. You use it in smartphones, for instance, to track your stairs, so how many stairs you climbed, or indoor navigation. But you can do also event detection. That's the second thing. And we are, as said, the best relative pressure sensor in the market, and it can measure that high output data rates that we can see very small variations happening from door openings. So actually, what I have here is not a demo which we show on the embedded world, but it's just a breadboard featuring an ESP32 microcontroller, our ENS220 on the demo kit, and an LED. And now, if you actually see the LED already, right? I will explain that in a second. But may I ask Guido now to quickly open the door of our meeting room, and you see what's happening? Yes, the LED. Close it. The LED is red, so that means it had detected a door opening.
And you will see it lighting up more, but you cannot hear. But there are other doors in the hallway. We should have maybe this meeting on after hours so that it's easier to see. But it is a really simple algorithm to implement, and it's something that people can already start playing at home.
Yeah, exactly. So we will not feature it at the booth because it's actually something available already to everybody. So just head to our GitHub or download the Arduino driver through the Arduino library manager, and you will have a ready-made example which you can feature this algorithm in. So maybe to point out also the door things, it's very sensitive. So we will even detect the front door opening. And now it's lunchtime, so a lot of people go in and out. That's why the LED shines up constantly.
But playing with the sensitivity, you can also determine where the door opens, how, if it is the immediate door of the office or doors that are further away.
Oh, so it's how? Just out of interest, what is the kind of relative pressure change when you open a door?
It's actually quite small. It's only some pascals, and it's like something like this. So like a spike, let's say.
And for reference, 12 pascals is 1 meter. So a couple of pascals, it's 20 centimeters. It's not a lot, definitely.
Yeah, that's very, very sensitive. Cool. So I've got some notes here for what we wanted to talk about, and apparently you've got a teaser of a parcel falling demo for like if you see these horrible videos where people like chuck the parcels over the fence or stuff like that, but I guess this would be useful for, I'm not sure if you'd call it tamper detection, but almost delivery competency monitors on parcels. So would you like to explain a bit more about how this works in this case?
Yeah, so the whole thing about making or tracking deliveries is that we noticed that our customers are putting our pressure sensor into trackers, which they put into their goods, and they want to track if it goes into an airplane and when it lands again. But this is not really challenging, and we thought, what can we give additional value to those customers? And since we have this nice relative sensing capabilities, we actually can detect very small height changes, as you also showed with the demo. And that's what we use in this parcel fall detection algorithm as well. So it can detect reliably if a parcel was falling to the ground. It can also give you back the height from what height it was falling. And that's one of the advantages, or for example, using an accelerometer, that there you can definitely see when you have a free fall, but then it's difficult to determine from which height you fell.
Yeah.
And also the orientation matters for the accelerometer, while the pressure sensor will always measure perpendicularly.
Yeah, because I guess if it's just sliding around, then you wouldn't be able to tell whether it's the difference between it sliding that way or actually falling. For an IMU. Excellent. So is that when will that algorithm be available for people to have a play with? Do you know?
So we are hardly working on that at the moment, and we plan to have a application node ready by next week, actually.
Okay.
And we also hope that we have the demonstrator actually ready for Nuremberg,
which was not the original idea, but we are actually making quite much more progress, and we are ahead of schedule. So that's why it's now maybe on the table.
Yes.
Oh, good.
And
oh, sorry. Continue.
No, please. I just wanted to mention, you mentioned about tamper detection, and that's also some idea that we are investigating, but it's on the infancy. It is in the
fair enough.
Because, of course, if you have a sealed package and you open, pressure sensors should be able to have a really nice idea of what happened.
Nice. And I guess since it's so low power to operate, then that's great for tracking labels and parcels and stuff where you might not even have the opportunity for harvested energy because they'll be in the dark.
Yeah, exactly. So we are really consuming microamperes. So if we sample, we consume 75 microamperes. But for this algorithm, we actually don't need constantly to sample, and we can use the interrupt functionality of the sensor as well. So you can turn down or turn off your microcontroller, or putting into a sleep mode, and actually wake up in case of a fall event.
Cool. So in terms of the size of these algorithms, are they pretty easy to implement on kind of the engineer's choice of microcontroller, or is there kind of a limit that you would say you need a microcontroller this powerful to do those kind of workloads?
Yeah, no, it's actually, we achieved quite a high reliability with a very simple algorithm with very simple computations. You still have to run the algorithm at least. No, it's.
That's right.
Yes, sorry. So we are acquiring samples at once every 2 milliseconds, but you don't actually need the microcontroller to pick up those samples so often because we have the FIFO. So you need only every 50 milliseconds to read the samples and to run it through the algorithm, which is actually quite fast. It just runs on integers. It doesn't do any strange computations. So you don't need an ARM or any powerful micro. I don't know if it can run on an Arduino microcontroller, probably, but we have to test it before I can ensure. But for sure, in the ESP32, it's no problem.
Okay. Excellent. Because you have your own booth at ScioSense as well as the presence on R. You have your own booth at Embedded World as well as ScioSense being a partner on the ipXchange booth. What can people look forward to on the company booth?
So on our booth, we will have all our sensors on display. So as you know, we are specialists in environmental sensing, saying gas sensing, humidity, temperature. And we are also experts in flow sensing. So also our ultrasonic flow converters will be displayed there. So for gas flow and humidity flow, water flow.
Excellent. So I think this has been a very good introduction to what's going to be happening on the ipXchange booth with ScioSense. Thank you so much for your thorough preparation for this interview and showing us all those demos. I wasn't actually expecting to see the balloon itself on the video, but I really look forward to the parcel demo when you've got it all up and running. So just let me know, and we'll have to do a little video.
Yes,
perfect.
Sure.
We will. And thank you for the opportunity.
Yes, thank you for having us, Eamon. See you in
no worries. It's always good. Yeah, see you in Nuremberg. And I hope your preparations go as smoothly as ours.
We hope as well.
That's
cool. So thank you for joining us at the ipXchange studios, and come and see us at Embedded World 2024 in Nuremberg, which is in a scarily few amount of weeks.
See you there.
See you there.
Yeah.
Bye-bye.
Cheers.
Bye.
Hey, where my engineers at?